Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
29.10, the equilibrium separation of the hydrogens in molecular hydrogen is 0.074 nanometers. So we want to use this information to calculate the energy and wavelengths of the photons that we get out of these rotational transitions of the molecule. So what we need is this h squared over 2i, h bar squared, sorry. And since we already know what h bar is, let's figure out what the moment of inertia is. So our molecule sort of looks something like this. This distance is r, and this is the center of mass. And since we're considering it, rotating about its center of mass, then, well, first of all, we're going to have 2, because we have a point rotating about some axis and another point rotating about the same axis, and they just add. And then, of course, the mass of a hydrogen atom. And then the distance squared for one of them, because we're counting them both with the 2 here. And so then this just simplifies to 1/2 mhr squared. And so then this characteristic rotational energy, h bar squared over 2i, is just h bar squared over 2 times this is mhr squared. And so this is 7.607 times 10 to the negative third electron volts. And so further, we have that the change in energy between, some L initial to L final is the initial L times this h bar squared over 2i we just found the value of. And then for a photon, its wavelength is hc over delta E. And so now using our value for h bar squared over 2i, we can find, just plug that in to this for each of our L values and also find the wavelength. So here our L initial is 1, and so just putting that in here, we get the energy is 1.5 times I'm sorry, there's a 2 here. I was confused for a moment. 1.5 times 10 to the negative 2 electron volts. And so then the corresponding lambda is going to be 82 micrometers. for B now, we have the initial L is 2. So we'll have 4 times h bar squared over 2I. Which gives us 3 times 10 to the negative 2 electron volts. And our wavelength is 41 micrometers. And then for C, our L initial is 3. So the energy of the photon is going to be 4.6 times 10 to the negative 2 electron volts. And the photon wavelength will then be 27 micrometers.